Okay, let's say you're given a problem like the one I've got here. So some kind of a complex function, h of omega equals 5 times 1 plus j omega over 10 divided by 3 plus j omega times 5 plus j omega over 400. And I've asked you to compute it at two different frequencies. So in this case, omega equals 10 radians per second, and omega equal to 100 radians per second, like that. Okay, those are the two things that I've asked you to do. Okay, so I keep saying you can do that pretty easily in MATLAB, and you can if you basically take the viewpoint that h of omega is a complex number, and so it has, at any given frequency, omega, it has a magnitude and an angle. Okay, h of omega. Okay. So at any given frequency, this guy's a complex number, and so he has a magnitude and an angle, or if I wanted to think of it, he also has a real part of h of omega plus j times imaginary part of h of omega. Okay, those are two equivalent ways of expressing it. We use this approach here with the magnitude and angle because that is how we use it with phasors. Okay. All right. So let's take a look at h of omega, and let's expand this guy out a little bit. The easiest way to do this, I think what you guys tend to do is you want to multiply these guys out. That makes this thing really ugly. I can think of h of omega as simply being, in this case, the complex number a times the complex number b divided by the complex number c times the complex number d, where a is 5, b is 1 plus j omega over 10, c is 3 plus j omega, and d is 5 plus j omega over 400. Okay, this guy right here could be expressed as magnitude a, magnitude b, magnitude c, magnitude d, like that. In other words, that's the magnitude of it. So the magnitude of h of omega is that. The angle of h of omega is the angle of a plus the angle of b minus the angle of c minus the angle of d. Right? Like that. Okay? So each of those is pretty easy to figure out in and of itself, right? So if I look at looking at these numbers right here, the magnitude of A is just 5. The magnitude of B is 1 plus omega over 10 squared. The magnitude of C is equal to 3 squared plus omega squared. And the magnitude of d is square root of 5 squared plus omega over 400 squared. Okay, important thing about this is these guys are just vectors, and if I take the magnitude of a vector is just the real part squared plus the imaginary part squared. And the thing to remember is the imaginary part is basically the coefficient of the j. A lot of times the way I think about this is if I think about these vectors, they have a real part and an imaginary part. The j is like the y hat unit vector that you have in physics. And the x variable here, the real part, doesn't get one of those unit vectors. Okay, that's kind of the way to think about it. And so it's just like taking the magnitude of any old vector. All right, now if I did the angle basically, so I'm just going to do one of them here. The angle of B is, in this case, the arctan of omega over 10 divided by 1, right? Because of the way that guy's set up. So how can I do that easily in MATLAB? Okay. Well, I asked to do this at two frequencies, omega equal 10 and omega equal to 100. So I'm going to make a vector that has 10 and 100 as the entries. And then I'm going to say that the magnitude of h is equal to, I'm going to plug in these expressions that I wrote down here. So I'm going to say it's equal to 5, is equal to 5 times the square root. So I'm going to put in the magnitude of b, the square root of 1 plus omega over 10 squared. But because I've got two entries in this vector, I'm going to say dot squared, like that. Okay? And then this result, if I just run this expression here real quick, so if I just evaluate that selection, okay, you see that mag h has two responses, two results at this point. Okay, so this guy is a vector with multiple entries. So what I'm going to do is I'm going to dot multiply it with the next entry. So I guess I don't have anything else on the bottom. So what I'm going to do is I'm going to say this is my numerator. And then I'm going to have my denominator. So I'm going to dot divide, because the bottom is going to be a vector of entries because I have two omegas that I'm putting in. So I do dot divide square root of c. So the magnitude of c is 3 squared plus omega dot squared. Okay. I got to be careful since my numerator has, or my denominator has two things in it. I can put my parentheses in it, and I'm going to dot multiply that by square root of 5 squared plus omega over 400 dot squared, like that. Okay, that gives me my magnitude at those two frequencies. So if I evaluate that selection and then look, there's my two results. Okay, this is the magnitude. The first one is at the frequency omega equal to 10. This guy is at omega equal to 100. Now if I want to do the angle, I do the angle of h, and I'm going to call this guy angle of h radians because the arctan function is going to come out in radians. All right, basically it's the angle of A plus the angle of B, and then I subtract the angles on the bottom. So the angle of 5 is 0 plus the angle of the next one. So that's A tan is the arctangent. Arctangent of omega over 10. Then I do the angle of C, and I subtract the angle of C because it's on the bottom. So here's C over here, 3 plus j omega. So I do minus A tan of omega over 3. And then I do minus A tan of omega over 400. And I'll put that in parentheses. And then say divided by 5, like that. All right, so that's the angle. And then I'm going to say angle degrees is equal to angle h radians times 180 over pi, like that. And then I'll evaluate these two. And I get my results. Okay, so what I can see, the first entry is the magnitude at the omega equal to 10. The second entry is the omega is the magnitude at omega equal to 100, and then the angle is similar, right? So the first entry here is the angle at omega equal to 10. The second entry here is the angle at omega equal to 100. All right. Now, you could have done this in a simpler way, right? If I wanted to, I could have done something like this. If I wanted to do it one at a time, I could just say omega equals 10, Then I don't need these dot divides because I just have one number that I'm playing with. So I take rid of all those dots because I'm just dealing with one number. And I evaluate this. And you see that I get the same answers that I got before for the first entry. And then I could do it again, and I could just plug in omega equal to 100. Right? This would be the way that I would probably recommend doing it.